Comparing Z-scores. Z-scores allow us to compare relative performance to the mean. Consider the following example. A student's exam marks for English and Maths are summarised in the table below. The marks are known to be normally distributed, so it's very important that that's stated somewhere. Because if it's not, then we really can't be using Z-scores. Or if you use Z-scores to compare marks, for example, it's assumed then that the data or the marks come from a normal distribution. So this student for English scored a raw mark of 75. The mean for that English exam was 65 and the standard deviation for that exam was 10. And for Maths, that student also scored 75. The mean for the Maths exam was 60 and the standard deviation was 8. So the question is, in which subject did the student do better, English or Maths? Now on the surface it appears that the student did equally well in both, since the student scored 75 in both English and Maths. However, by calculating a Z-score, we can then make a comparison of performance relative to the average for each of those exams. So what we're going to do is we're going to calculate a Z-score for each subject using the Z-score formula. So for English, okay, the Z-score is the raw marks, so 75, minus the average or the mean for English, which was 65, divided by the standard deviation of 10, and we get a Z-score of 1. For Maths, we use the same formula, of course, so Z equals 75, that's the raw mark, minus 60, so that's the mean for Maths, divided by the standard deviation for Maths, which was 8. And we end up with a Z-score of 1.875. So from that, what we can see is that the Z-score for Maths is higher than the Z-score for English, even though both raw marks are identical. So we can conclude that the student performed better in Maths compared to English when compared to their respective means. So look, there could be other reasons why the mean was low or for whatever reason, but if we're just comparing the raw mark, so these raw marks to the mean, we can then make a judgment call as to how that student performed relative to the average for that subject. Now, if two different marks have identical Z-scores, this means that the relative performance is identical. So for example, if a student scores 90% in Maths and 70% in English, with both Z-scores equal to 1.5, this means that the student performed equally well in both subjects when compared to the mean for those subjects.